So I went to Berkeley because I was in statistics, and they didn't have MIT didn't have statistics, and literally, and they still kind of do now, but not so much. And I think that was really crucial. To me, computer science was really exciting and all, but it hadn't yet embraced the problems of inference. And to this day, I think there's still a disconnect. So I went there to learn about probability and statistics, and I have. But they said, okay, you're interested in statistical kind of stuff. You're in machine learning. That means you're in AI. I said, no, you don't get it. I'm not in AI. I'm in machine learning, maybe, if you want to call me that. They said, well, isn't that just AI? And I said, no, it's really much, much broader. It's all of computer science should have learning in it, everywhere. All the infrastructure should have data flowing in. You should make changes based on adaptively. It's all of computer science, isn't it? And I'd say to this day, I still don't get a lot of resonance in the computer science department for that statement. They still think it's part of AI. Now, of course, I've lost the argument, because now you see the buzzword AI everywhere. And I can't tell you how much that irritates me. First of all, it's intellectually dishonest. We don't have artificial intelligence. We don't have intelligence yet. We don't really know what it is. We have systems that take in data, input, output data, and they mimic something that's intelligent. They just mimic it. Guys, that's not intelligence. We don't have it yet. And so for us to be using that buzzword, we are selling something to VCs, to companies, to journalists, to the public, which we don't have, okay? So fine, I lost the argument, but I have to say that and get it off my chest from time to time, okay? Now, I'm glad to hear there's a community developing here, because to me, what's really needed is, in fact, an engineering effort that's serious and sober, not full of all the hype, not full of all the gold rush trying to make money, just trying to build things that make the world a better place and make it robust and real and deal with the concepts you need to build a brand new engineering science. I think of it as somebody like civil engineering or chemical engineering, fields that I have a great deal of respect for. There existed kind of proto-chemistry and buildings and all that, but they developed something serious that changed everybody's life for the best. That's what we need here, and that's what we precisely don't have yet, okay? So let me start now with a little bit of philosophy. ML has come of age. I clearly, 20 years ago, I already knew that ML, all of us in the field knew that ML was going to come of age. There was going to be data everywhere, and it was going to be used to make decisions, and business models will be built and everything. And so again, I kind of resent that it's now suddenly be called AI, even though there's no new ideas from AI. It's just machine learning. All right, but fine, I lost that argument. But it's not as solid engineering discipline yet, and I'm going to kind of pursue that during my talk a bit. There's no magic. I don't think I have to emphasize that too much, but it really is just taking its input-output mapping, it's mimicking something in the world. How can that be magic? And there are lots of hard problems that are really systems problems in many ways, in a broad sense. But systems that include economics, so I'm going to emphasize that as well. We don't think enough about the pricing and the incentives when we build systems, and we should be, okay? And systems that include social and legal issues. I think now everyone's a little bit aware of that, but it really shocked me how long it took for people to become aware of that. And when Mark Zuckerberg, God love him, stood up a year ago and said, I don't have anything, I don't have any role in this. It's just we build a platform, and how it's used, we don't have anything to say about it. He turned on that later, but that was shocked me that people hadn't gotten it. All right, so great care is going to be needed, not just to do bad things like fake news. There's all kinds of other bad things that are going to happen if we don't get this right, like bad medical decisions being made for hundreds of thousands of people per day, bad transportation decisions, bad finance decisions, and so on. We're not even close to being able to solve those problems, and we're acting as if we are. So systems ML, to me, is aiming too low. Right? People in this community still have bought in too much to the deep learning hype, that we have this great learning machine called backpropagation, and all we got to do is make it better and faster and more accessible and all that, and by God, such magic will happen. Well, yes, good things will happen. Companies will be built, economy will go forward, but it is aiming too low just to do that, okay? That is just a non-parametric regression. It's not even close to enough, okay? So I hope as a community we aim higher than that. We don't just try to make it easier to do backpropagation. Okay, so let me say a little bit why I think this kind of has happened, that this disconnect has happened in people's minds. So when I was around, I was taught a little bit about AI. I didn't really study it that much because it didn't seem like there was a lot of ideas there. There was breadth first search, fine, A-star. But it was, what was it? Well, it was John McCarthy, really, at MIT, and I gather the story is a little different than it's often told. It wasn't Minsky and McCarthy and all sitting, and Newell sitting at a conference. Apparently McCarthy arrives at MIT, he says, I want to work on intelligence and computing, And then they say, well, isn't that cybernetics? We already have Norbert Wiener who does that. And he says, no, it's different. And so how's it different? Well, so he couldn't really convince people. It was based on logic more than on control theory, signal processing, optimization. So anyway, he had to give it a new buzzword, and he invented artificial intelligence. So that, I think, is something closer to the actual story. And the bizarre twist of history now is that all the ideas are on the Wiener side. It's all optimization, statistics, and so on, but and no logic. But the buzzword being used is McCarthy's buzzword. So it's hilarious. Anyway, that was an aspiration, and I still think it's a great aspiration. I don't want to demean the aspiration. I'm trying to think about the philosophical problem. How do you take a computing entity with software and hardware and build something that captures something of our intelligence? It's a fascinating thing to think about. I think of it still as an academic aspiration. I don't think it's either necessary or sufficient for progress in industry. I don't believe this notion that we build general intelligence and therefore that general intelligent object can solve the world's problems. That's silly science fiction. It's neither necessary nor sufficient for solving engineering problems, and it is taking our minds off of some of the real problems. Okay? And if people weren't sort of famous people with lots of money behind them saying things like this, we build AGI and therefore we can solve world's problems like cancer, I wouldn't have to say this, but people are saying stuff like that. All right, nonetheless, that is to this day an interesting perspective. It's not the whole thing we should be working on, but fine. In the meantime, what really happened was not that AI was pursued with great success. What's often called IA was pursued more with great success, intelligence augmentation. So I think of search engines as this. They are a machine learning system. They take in data, they improve themselves over time to make better and better decisions. And it's an algorithm, it's a machine learning algorithm with a lot of other stuff around it, like any other realistic engineering system. It's got lots of things around it. But it augmented our intelligence. I don't have to remember now the capital of Belarusia, whatever it is, bang, 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 I type and I get it. It's in my brain within milliseconds, and there I seem like I'm more intelligent. I know everything now. I can also speak in English in this, and Chinese could come out. That could be rigged up here. And so it's as if I can now speak multiple languages, or lots of languages. I do speak multiple languages, but I don't speak Chinese. But I can now because the computer has augmented my intelligence. And I actually think a lot of this stuff with deep learning, which I don't want it to diminish. I think it really is interesting. But one of the things you see often is people will take in images and they'll transform them into other kinds of cool images. Like it looks like Van Gogh painted it, or something like that. That's really interesting. It's a toy, but what it does is it augments people's creativity. It's an augmentation. It's not intelligent per se. But that's already interesting. Or you can do musical kind of things. It's not going to write a symphony. That's silly. Who cares if a computer could write a symphony, whatever that might mean. But that it can give a palette for the next emerging generation of brilliant artists, the Beethovens or whatever, that's exciting. Okay, so that's IA. But I also think there's something I'm going to call II, which is even more important, which is, let's call it intelligent infrastructures. And it's what we just see all around us. The world knows more about us. The world is more connected up. I can pull out my cell phone and I can have a car ready for me to go in a few seconds. And it'll take me where I want to go, and it coordinates, and all. The world is just becoming more intelligent. It's network. It's so Internet of Things, whatever you want to call it, plus data, plus humans in a big, complicated system, right? That's really, that's trillion-dollar economy issues, and that's changes people's lives. And it's, if you think about the medical world, the finance world, and all that, there's just huge, huge things to be done here. Right? And that's, again, already happening over these decades. I think of Amazon as the first company that started to do this seriously, already in the 90s. So well before the hype that we're seeing right now. There were companies building logistics change, predicting fraud, recommendations, all those kind of really great things. That was all machine learning. It wasn't being called AI then, and I think it was more exciting than what we're seeing right now. Okay, now why do I have to make up such a big deal about this? Well, I think there's a disconnect, and maybe it's just terminology. But if you study AI in this classical kind of way, you're interested in vision and speech and natural language and robotics. Because you're interested in this embodied agent, which is going to act intelligent like us. And so the algorithms you think about are those that are associated with an embodied agent. Right? And so you can develop algorithms like backpropagation that take in scenes and turn them into objects or label speech and all that. And that's all great, nothing wrong with it. But that doesn't solve about 1/10 of the real problems you have to build to do a real world system that does IA or II. And people's attention is being distracted to that. We have to support the vision people and the speech people. right? So I'm trying to, actually before I get there, I think I'm going to say something about that. Are we really kind of getting close to having those problems be solved? And again, in my provocative old man's early morning grouchiness, let me just sort of say no. I think we're really far from solving even these classical AI problems. So computer vision, we can label objects and scenes way better than we could before, no question about it. But they're not really scenes. They're images taken from the internet where there's an object in the internet that someone took a picture of. Right? If you take that same neural net trained up to 90-some% on ImageNet and pull that in the real world, I think it's about 20%, if I understand correctly. Okay? Are people aware of that? Come on. We haven't even solved that problem. And that's just labeling the objects in the scenes. That's not talking about the meaning of the scene. What's going to happen next in the scene? What are the verbs in the scene? Who's doing what to whom? We're not even close to that. So people saying that computer vision is nearly getting solved, come on, this is ridiculous. Same thing for speech and for sounds in general. We live in an auditory acoustic environment. We're so far from being able to do what a person does when they close their eyes and understand the world around them by listening to sounds. That, it's the same thing, no semantics. All right, and don't even get me started about NLP, all right? All right, translation is not taking a long string in one language and turning it into a long string in another language, as you've seen lots and lots of strings in the past, right? I speak fluent French, and so you can tell me something in English, I will understand what you said, what you're referring to in the world, and then I will, by my conceptualization of what you're saying, I will turn that into French. I did not take my string of English and map it into a string of French. I can guarantee you that, right? And so yes, you can make some progress, you could get up to 90-some% in some score, right? But it's not going to work. It's going to die. It's not going to make it all the way. And even if vision makes it all the way with those kind of techniques, with supervised labeled stuff and some unsupervised, natural language is not. And so if you don't trust me, read David Douglas Hofstadter has a beautiful article in The Atlantic the other day, just sort of making this clear, okay? That language is just really is all about human intelligence, about irony, about metaphor, about reference, about all kinds of things. That requires understanding the semantics of the world, it requires understanding human social behavior, conceptual behavior, and it's not you're going to get it by labeled data and lots of strings to strings. Okay, so I said don't get me started on natural language, I kind of got started, but that's just translation. Think about dialogue. Dialogue is not just a chat bot where you sort of send strings back and forth to each other which happen to sound interesting because they're strings that people said in the past. It's trying to get to a goal. I want a flight to Paris, and there's all kinds of complications to get me there, and I have all my kind of preferences. So we have to have a dialogue that eventually hones down on an actual action in the world, all right? And we're very, very far from that. Robotics, a lot of progress there, but I'm pretty skeptical. I think it's really still just robots in very limited situations in the industry. The idea that we're going to have robots that really interact with us, again, I don't think it's in our lifetime. Okay, so now let's get a little more technical. So if you are a SysML person, and if you think your role in life is to support the deep learning wave, fine. I do think that is very, very useful. But here's a whole bunch of other things that aren't kind of even what I would call AI. They're II, okay? Multiple decisions, okay? Statisticians talk about this all the time, and people in machine learning still to this day hardly talk about it at all. You can build a neural net that takes in some image or some even maybe history of something and makes a decision, and then you roll that out, and it makes that same neural net's making 100,000 decisions for different people in different situations concurrently. That can be total disaster. Those decisions can be totally correlated, right? It could be that you're making transportation decisions and it happens to be rainy today, so everybody does something different. They all end up going to the same street or something. Or in medical situation. So fluctuations of correlated decisions cause elections to be changed, even though, because it's not IAD. All right, we're still acting as if we're in an IAD world. All right, so there are things like false discovery rates. Learn about them. Systems should support that. Your system should not just support logistic regression, decision trees, and neural nets. They should support false discovery rate control. Okay, if your system doesn't do that, I don't want to roll it out in my company. I think there's a huge number of opportunities for systems that create markets, and I will talk a little bit more about that. So we put economics into our systems, and we have bi-directional things, consumers and producers. Not just build a platform that people can upload data to and get answers from, but actually build a system, a real system. And then I went through a lot more here. Uncertainty, still to this day. We know in statistics we talk about bootstrap and Bayesian and jackknife and so on. Those principles still aren't sitting inside of our computing science systems. Okay, it just, Input comes in, output comes out. I give a ROC curve, and I'm act as if I've done my job. I haven't. I need error bars. Cloud edge interaction. Now we're talking about something really more computer sciencey, but it's not classical AI, you know. So where do you put the intelligence? Is it at the edge? Is it in the cloud? How do you manage the fact that it's going to be incoherent between the two? Those are really critical problems, and we have to work on those. You can't just assume that they're, you know, to be handled by the boring side of computer science. Abstractions. Humans are extremely good at finding abstractions really, really quickly, right? I can kind of tell you I can invent a new word, bletch or something, and I can say a couple of things about a bletch, and you'll now know all kinds of things about it. You can reason with abstractions. You can, in fact, when we do good computer science, we're creating abstractions. That's what it's all about. My children are extremely good at seeing analogies and metaphors and kind of finding, oh, that's like that, and suddenly a new abstraction is in their brain. That's so far from neural nets that have to see huge amounts of data to finally uncover a new feature representation that someone argues is an abstraction. Okay. Provenance. This to me is really critical. In fact, I got interested in data science. I have a medical story that I could tell you at some point about false positives that I think were generating lots of deaths, and it was about when my child was born. There was some imaging result that was a false positive that if we had gone down the wrong path of decision tree at that point would have been a very dangerous procedure that probably would have killed the fetus. And I think that did happen to, you know, I calculated about 20 people that day, every day for a few years, babies. Were being killed because of a false positive. And the false positive didn't have to do with bad statistics, it had to do with bad provenance. A data analysis was conducted in one situation which was not really exactly the same situation as with the new imaging machines. All right, so that sounds like a boring database issue, and it is, but it's the thing that makes things work or not work. What else? A lot of these other things people have talked about, explainabilities, you know, causal, you know, what about long-term goals? I mean, humans are extremely good at pursuing long-term goals. You know, I'm gonna have a career, I'm gonna buy a house or whatever. And our machines just don't have that. You know, don't talk to me about reinforcement learning. Reinforcement learning does not have long-term goals. Okay. Real-time performance goals. That word real-time, you know, just does still not mean enough. It really needs to. I mean, people who are building self-driving cars are quite aware of this, but a lot of other people are not aware that it's a critical part of our thinking. And again, it's not part of classical AI. You know, fairness, diversity, a lot of people have talked about it, and so on and so forth. And sharing data and privacy are also all part of building a really good system that really works in the real world. And it's, you know, part of this broader II set of issues. So I could go on, but I hope you sort of see that if you're a real ambitious systems person, these are major issues that are unsolved and mostly not talked about. And some of them are talked about a lot now, but it's taken a while. Okay, so I'm going to talk about, so I've learned, some of my perspective is shaped as much by my research as by going to companies nowadays. So I'm going to talk about two of them that I've been involved in on scientific advisory boards that kind of have helped shape my thinking. In fact, my real work now is I'm just a theoretician. So all this nice wave of neural nets and very, very empirical work, I'm just happy it's happening. But when I see everybody going in one direction, I head in the other direction. So I do all my work now really trying to prove theorems about, you know, convergence rates and stochasticity and asynchrony, distributed, and all that, and real theorems. So if you look at my webpage, that's what I'm really excited about these days. But I'm getting my perspective shaped just as much by going out to companies and not proving theorems. So let me tell you about one called United Masters. This was a company, it's around here somewhere. It was announced in November. It's about music. So more music is being made now today than ever before by order of magnitude. Because SoundCloud, you know, is sitting there and people have their laptop, and really creative people can actually on the weekend create music. And they do. And it's really good, a lot of it. And more people are listening to that than ever before. They go to SoundCloud or they go to Spotify or whatever, they listen to it, right? But to first order, no money's being made, except by a few people that still hold a few reins of power, right? The people who are making the music are actually not getting paid for it. All right, now, is that bad? Yes, it's bad. It's bad for many, many reasons. We have a broken market. We don't have an economy. There's so much value that could come if that economy were to be started that connected those producers and those consumers. And it can't be the old one where you have record companies sitting between them and, you know, handing off money and all that. That's just not going to work here, right? So you have to do something else, all right? So what do? Well, again, I think it's kind of like Uber or whatever. You see a real opportunity here. So United Masters has done the following. They've partnered with Spotify and YouTube and so on, and they get all that data. And they learn for any artist, not just the Beyoncés of the world, but the next 100,000 artists down who are not as well known. but they learn for each of those artists who's listening to them, okay? And they provide that artist with all that a dashboard, right? And the artist then gets to see, well, I know I'm not super famous, but it turns out that in, Jacksonville, Florida, there's like 10,000 people who like to listen to me on a regular basis, because, word of mouth or whatever, it happened. So that means if I go there and I give a concert, I'll make $25,000, all right? And if I do that 3 or 4 times during the year, that's $100,000, that's a salary. I don't have to be a taxi driver and then make music on the weekends. I can actually be a real living, working musician, right? And that's not just one person, that's, large numbers of people, all right? So that starts to create a market. All right, then the person, you can do more. You know who's listening to you. There's actually now a connection between producers and consumers. And in that connectivity, goods can pass. Once the data flow is passing, goods can pass. So in particular, the artist can say, hey, I'll play your wedding for $20,000. Or you're a super fan of mine, you want to come backstage, and so on. All those good things can happen. And then the company that provides this can make some money. They will. They provided a platform, and they should get some money, but not 50% like a standard agent, 10%. Okay, so United Masters is the real thing. It's got really high-powered people on its technical board, or it's on its board, including real-world famous musicians who I won't name because it'll sound like name dropping. But the CEO is a person named Steve Stoute, S-T-O-U-T-E. And if you've never heard of him, go look on the internet a little bit. He's an amazing man, one of the most smart people I ever met. And he has already created an advertising agency. He's been at Sony Records. He's just done a lot of real-world things, and he knows a lot of musicians. When he was married, Kanye West was his best man, and so on. So I did name drop a little bit. But Steve is positioned amazingly to bring technology together with people in a context of music. And so I think that's really exciting that our community can participate in that kind of thing. And Steve gave the keynote, not the keynote, when I was chair of statistics this last year, I invited him to give the commencement speech, and he did. And it was brilliant. It was about all the kind of the themes in hip hop about self-empowerment and liberation and creativity and all that, and how that matched up with data science. He wasn't calling it AI, he was calling it data science, and it was brilliant. So anyway, that's an interesting company. Go look at it. You might, if you're looking for a job, that actually was the kind of they're hiring, and it's a very cool startup kind of environment to be in with really cool people, and you do get to meet some famous musicians. Here's another one that I'm involved in. This is in China, Ant Financial. So how many of you have heard of Ant Financial? Just out of curiosity. Okay, pretty good. Alibaba, how many of you have heard of them? Okay, even everybody. Yeah, so Alibaba is sort of the Amazon of China or the eBay or whatever. But it was a very different situation when it was created, 10 or 15 years ago. In China, the first order, no one had credit cards. So when Amazon created it, they said, okay, upload your credit card, and then we'll do all the fraud detection really, really well with machine learning, and we'll start to sell you things. Well, in China, there was no credit cards, so they couldn't do that. So they created Alipay, and Alipay was just was an online payment system. And then it started to get used by half a billion people. And so they had a fantastic system behind that to do that, Alipay. And then they had the brilliant idea, well, this is working so well online. Offline, we have the same issue. People don't have credit cards. So let's just do it offline as well. So let's go around to every merchant in China, give them a little device that people can hold their cell phone up in front of and pay. And this just took off. If you've been in China the last 5 years, it's amazing. Grandmothers pay with their cell phone in herbal shops. I mean, it's nothing like here. And so everyone was using cash before. They don't use cash, they use this, right? So now this company, which became called Ant Financial, they split off from Alibaba, has the world's best data. It's not just data like Facebook or Google, where you're getting people clicked on something, therefore they must be interested, thank you, in that, and trying to infer that, and then what do you use it for? Well, advertising dollars. It's to me a much more interesting thing. You're getting transactional data. You get that I like to go to Szechuan restaurants, or I buy music, or I whatever. You know a whole lot about me and things that in some sense I'm kind of happy because that's, if you can provide me more goods like that, that's a value to me, all right? So the first thing they did was that they started to provide credit. So from one day to the next, a little button would appear on someone's phone where they could push it and they could ask for a $1,000 loan. And this is a grandmother in a rice paddy in China who suddenly has access to credit. Think about how revolutionary that is, how amazing that is. All right, and I think that if I understand correctly, the story is that the banks didn't get outraged by this. because the banks weren't interested in the grandmothers in the rice paddy. All right? They're not interested in trying to serve 500 million people. They can't do it. They don't have the IT skills and so on. So they just try to serve the rich people, somewhat just like the US. All right? So Ant says, no, our game is going to be democratizing finance. And to me, that's really interesting, because in the US, I'm used to finance and democracy not ever going together. Finance is for making rich people richer. Isn't that what hedge funds do? But in China, for this odd historical fact, there was no credit card industry to fight back against this. They were able to do this, start to do this. So they provided credit. And now they can start to provide other kinds of things that are really goods, recommendations. So I can recommend restaurants to you, and not just recommend that's a good restaurant to go to, but actually connect you to the restaurant, just like in the music situation. And the restaurant will know you're in town, and the restaurant can make you a discount offer. That's real economics. All right, now why is that interesting? Well, for many reasons, not just that it makes people happier on some level, but it also solves some very serious problems with recommendation systems. All right, so classical recommendation systems were built by machine learning people who were just thinking about building a platform and not thinking about building an economic system, right? Well, if you build a platform, you can do the following. So if I build a platform for movie recommendations, I can recommend the same movie to everybody, Black Panther tonight, right? And there's no problem. I just stream the same thing to everybody, right? Or I can recommend the same book to everybody, and that's probably not going to be a problem either. What if I recommend the same restaurant to everybody? And, you know, big problem. They all go there, and there's a huge, you know, line, and everyone's unhappy. What if I recommend the same stock to everybody to buy today, because I'm doing financial services? Big problem. Destabilize the market. All right. What if I recommend, you know, the same destination to everybody? Big problem. Traffic jams. Right. So I got a load balancing problem. How do you solve load balancing problems? Well, computer science mentality. Well, I build the system so that it balances it. You can't do that at the scale of 500 million. All right. So how do you do it? Well, economics, markets. So it's actually not that hard. You build a two-way recommendation system. Right? You go to everybody who's a consumer and you give them an app on their cell phone that when you come out of the movie tonight, it says, you know, here's some restaurants to go to. But you build a different app for the people in the restaurants. They, at the beginning of the night, say, oh, tonight I've got a wedding and, you know, taking some of my seats, but so I got 50 seats left to give, and I prefer people from out of town and young people and people who've come to my restaurant before, whatever, some policy. Then the policy starts executing, and so at 7 p.m. it says, oh, I see that Jennifer is in the neighborhood. I know she likes Szechuan cuisine. Jennifer, you get a 10% discount offer for the next 10 minutes. And if Jennifer signs on, bang, I've got 49 seats in my restaurant. And that keeps going until I don't have any more seats left, and then no more offers are made. Right? I did my load balancing. But moreover, it's a market. And that means that all the other restaurants see this happening, and they say, big opportunity, our big competitor, that favored restaurant's full tonight. I'm going to make 30% discount offers to them, eat, and so on. And I'm going to fill my restaurant tonight, and that's great. So that's what's called an economy. And you've built it just by having the data and providing it to the right people at the right time. All right? So isn't that much more interesting than just building a Facebook platform that, you know, I shouldn't say things like this out loud. But really, actually, it solves, Facebook has got a very serious problem, which is that, you know, in 5 years, all the kids could say, Facebook, that's lame, that's the old generation, right? And they are saying that. They leave because it's not cool to do what your parents did. And social media has that problem. So what does Facebook do? Something I consider very unhelpful. They just buy up the latest company that looks cool. All right? Much more cool to build a system where people are actually getting economic value out of being in the system. The restaurants recognize you, and they make offers to me because they know about me. And there's a little point system, like a United Airlines has points for me. I kind of like that, right? And if I leave the system, I lose my points, so people won't leave the system. It's a way better business model than Facebook's. Okay, so why am I saying all this? Well, to me, these are the issues that we as a community can and should be facing, okay? All right, so what else do I have to say? Okay, so here's another one, data sharing. So a lot of these are just thought experiments. If I got 5 minutes, so a lot of these are thought experiments. These are research proposals. Some of my group will probably work on things like this, but we're mostly proving theorem these days. But here's another one that's a thought experiment. Data sharing. This is another, not an AI problem, but it's a real world II problem, which is that if I have lots of people, lots of companies that have data that if they were to put it all together, it would be helpful to them. They often are not allowed to do that. The lawyers don't allow them to do that, or for many reasons they don't do it, administrative or so on. So think about fraud detection or intrusion detection. on any given day, a company might get hit by a new intrusion or a new fraud, right? But it probably won't go to all companies simultaneously. It'll probably get hit one particular company. If everybody were to aggregate their data, you could build the world's best classifier and you'd keep the fraud level way, way down. But people don't do that, right? Why? Well, many reasons. How might you incentivize them to start to provide their data? You'd like them to say to them, well, send all your data to me as the trusted central person, and I will protect, we'll just do it with cryptographic mechanisms or whatever, and I'll take your data and I'll build a perfect classifier and I'll send that back to everybody, and I won't share your data with anybody, all right? But that's not very interesting, because it could be that, so let's do, Bank of America, MasterCard, and American Express. They all have fraud data, right? But maybe that American Express just has way better fraud data than anybody else because they're just bigger or whatever, right? So if they put their data in the system, the others get much more advantage than they do, all right? So they know that, and they're not going to send good data. They're not stupid, all right? But how good of data should they send? What mechanism, what incentives are there in the system that allows them to kind of gauge how good of data to send? Right? And moreover, they do have privacy issues where their lawyers are sitting there saying, don't send the data. Right? So here's a way to do it, I think, from a machine learning perspective, which is that you let each one of those companies make their own decision about how to do differential privacy or whatever, so they're comfortable. They add some noise to their data and they send it up and they're comfortable with that in a differentially private system of some kind. All right? Now the data arrives to me, and what I'm going to do is I'm going to build a classifier based on all of the data and see how well it does on a holdout set. And then what I'm going to do is hold out one of the company's data. So I'm going to hold out the not Microsoft, I'm looking at Jennifer. I'm going to hold out American Express, and I'm going to train on the other two, Bank of America and MasterCard, and I'm going to get a classifier. And I'll see how well it does. And I'll compare the two, right? And if I did way better when I included the Bank of America data, that means that must have been good data, all right? I can quantify the goodness of data just using a loss function in our classical holdout way, all right? And now I can do that for each of the companies, leaving them out one at a time, and I've assessed how good the data they sent me. They decided how much data to send, how good it was, how much differential privacy to invoke, fine. But now once I get it, I can evaluate it, right? And now what I do is I build the world's best classifier on all their data, but I send the model back to them, or the predictions or whatever, with noise added inversely proportional to the quality of the data they sent me. But you're laughing because I've just set up a game, and that's what economics is about. It's a game. All right, and now there's some notion of incentives, and there may be a Nash equilibrium, which is not that no one sends anything. Okay, so that proposal may or may not go. Research may or may not result, but I think it will. So anyway, I think there's lots of ways to think that if you get out of our kind of classical look, and I think this community is in many ways the one to do it. I don't think the deep learning people are going to get there. Now I'm down to 1 minute. All right, so the last thing I want to do is just do a little bit of advertisement. I am involved in a project that tries to do some of the other things there on the list, real-time decision making, distributed things and so on, and reliable and good engineering. And that project's called Ray, and the two lead researchers on that are in the audience. It's Philip and Robert, and they have a poster today. So this last part, since I've down to 1 minute, is just advertisement for this. And let me just sort of show you a slide or two. Ray is aimed to kind of be very good for very large numbers of small heterogeneous tasks that have different time scales. So think reinforcement learning with stochastic rollouts, where you go down one branch of the tree, you learn very quickly that was a bad idea, right? Whereas another branch of the tree, you go on and on and on because it's looking good, and finally it's not so good. Well, that could take 10 times longer than this. And so in kind of a Spark or a MapReduce parallelism context, you have to wait for everything to finish. It's block synchronous. Wouldn't it be great if once that is realized that it's a bad idea, you can immediately start up another process? So you have more of a data flow kind of tree. So make that into a system with the reliability associated with MapReduce implementations and the scheduling issues being handled well and so on and so forth, and that system is being called Ray. And it exists, and it looks something like this. There's a huge amount of scheduling going on locally and globally. There's a lot of object store issues and how you keep coherence among the different distributed processors and so on. Ray scales extremely well, linear scaling here in a particular set of experiments. It's very, very fast. There's 1 million tasks per second being realized in the current working software. Here is just a little example of one of these, let's make a reinforcement learning kind of learning problems. Let's make a robot run just by giving it a signal that it's good to run in this direction. And it's a real robot. It has kind of muscles and 60 joints and so on. And here's some code that makes that happen. It runs a simulator in parallel in a dumb way. That's what reinforcement learning is, just dumb, run a simulator in parallel. But it makes it real easy to do that. And here is a video just to finish. So Philip, who's in the audience, did this. This is a pretty good example of, near real time, after 500 iterations, this thing is going to learn to run. And why am I showing this? Well, because it is fun to be an AI guy and show robots. And, I don't usually get to do this, but there you go. Okay, so let me, there it is. At 200 iterations, it's done really pretty well. And I think, can we wait, Ginger? It's so nasty to start a video up when you have 0 minutes left on your schedule. All right, so, all right, stop. Can I go to my last slide? All right, there was, okay, I'm stuck here. There was a last slide that has the GitHub address for Ray up there, but if you're interested in participating in Ray, it is an open source project, and there's a GitHub address, and there are a lot of people around the world currently starting to participate, and we really want to roll this out. And let me again point over to that part of the audience. Philip and Robert are sitting over there who would love to talk to you about that particular systems project. Thank you very much. I guess I was too provocative.
Hello?
Please.
Okay, hi, Mike. Thank you for this talk about these great opportunities and challenges in this world. So basically my question is, what do you think is the kind of the most important keys that prevent people from already having solved this problem? Is it because that we're too kind of lazy to even think about those problems, and we can basically just use the deep learning to solve the problems? Or is it because we are lacking of great models or kind of new machine learning models or economy models or whatever other models? So we have to invent kind of new technologies and really new models of the problems? Or is it because some other reasons, like we're lacking kind of a system opportunities or system architectures that are not being invented yet? So basically, that's a question.
Yeah, great question. So I hope the overall tone of my remarks was not, you don't take away just the criticism and the jokes or whatever, but really the main message is that civil engineering, chemical engineering, so these took decades, if not centuries, to make real, all right? And we're trying to build the mother of all engineering fields, right? This is harder than chemical engineering and civil engineering. It has to do with human intelligence and computing and all that, and it's going to take at least decades. A long time to get it right. And there's lots and lots of hard slogs. And so it's not going to be on the, in my 5 years as a grad student, I realize AI or even, I just don't believe a lot of these companies that sort of are arguing that they're on the, they're going to provide it. It's going to be a big societal effort, and we got to be careful about it. And we want to help people. We don't want to hurt people. And so we need new concepts. It's not just build good systems. It's brand new concepts are going to be needed, and they're going to be systems concepts, a lot of them, and they aren't going to be the classical ones from classical computer science. There's some good ones from classical computer science, but there'll be some new ones. So it's just trying to get you excited about research, but broadening the scope of the kind of research that we take on. So I'm not trying to be that critical about what's going on. I'm glad of all the energy, but I do think there's a lot of naivete right now, and a lot of awareness that we're trying to build an engineering field, and it's an engineering field that critically involves humans. Chemical engineering didn't really. It was about the physical world, similar to civil engineering. This is the first engineering field ever, I think, which is critically a human-centric engineering field. And it's going to take a long time to kind of make something worthy of talking about. So I wish we had just sort of kept going with that and not gone onto this crazy deep learning, go to the journalists, talk about how exciting it is. I just wish we just kept building this field, and I think that's what we will do. So, but just want to emphasize that. Yeah.
Cool, thanks.
Thank you for the wonderful talk. So I'm curious, when you mentioned the opportunities in building machine learning systems for markets, do you have in mind mostly like incorporating these practical economic concerns into existing supervised learning models, or are you more advocating for like a new paradigm of learning, something closer to, I don't know, active learning or even completely new?
I mean, I'm always advocating a new paradigm. I mean, I mean, really, come on. We're so far from having the real concepts.
Okay.
And just taking, an econ book with a CS book with a stat book and gluing them together, that's not going to do it.
What do you think is the most promising so far for these ML systems for markets?
Well, I think recommendation systems already kind of pointed the way a little bit. So I think, I mean, in some sense, Uber already does this. They have drivers and they have riders, and they have different apps. That already is a two-way system.
All right, thanks.
So yeah, no, I think it's not that impossible to think about.